Hello, welcome to this tutorial in which I'm going to have a look at another examination style question on circle theorems. This is the fifth one in the series. In this particular one it says B, C and D are points on the circumference of a circle, center O, and AB and AD are tangents to the circle, and the angle BAD, this one here, is 70 degrees. We're asked to work out the size of the angle BCD, this one here, and to give a reason for each stage in the working. Okay, well, you might want to pause at this point, have a go at the question, and come back and have a look at the solution and your answer. Okay? Right. Well, the question says that AB and AD are tangents to the circle, so it means that tangent and radius property comes into play here. OD is a radius and D is a tangent, so the angle ODA is a right angle, it's 90 degrees. The reason? Tangent and radius meet at 90 degrees. Similarly, OB is a radius and BA is a tangent, so the angle OBA is also a right angle. This is quite nice because we now have a quadrilateral, BODA. And what do we know about the angles in a quadrilateral? We'd add up to 360 degrees. That means we can find this angle here, the angle BOD. Okay? So I'm going to move on to the next page. And here's the diagram again, with the angles marked in. So we first of all need to write down that ODA, angle ODA, is 90 degrees, and the angle OBA is also 90 degrees. And the reason is tangent and radius meet at 90 degrees, because we're asked to give reasons at each stage. Now, what do we know about the sum of the angles in a quadrilateral? Well, I'm talking about quadrilateral BODA. The angles add up to 360 degrees. So, angles in a quadrilateral, I write quad for short, add up to 360 degrees. But we already have two angles, each 90 degrees. And that's the angle ODA, this one here, and the angle OBA. So if we take 90 and 90, which is 180 from 360, we're left with 180 degrees. So I can actually write down the quick way to find BOD is to say BOD is 180 minus 70, which is 110 degrees. So I can write in here 110 degrees. If you prefer, you can still say that BOD is 360 minus 90 plus 90 plus 70, and you'll get to the same result, which is 110 degrees. Having found the angle at the center, which is 110 degrees, that angle is facing the arc DB, the minor arc DB, this arc here. Now, which angle at the circumference is also facing this arc? And we say they're subtended by the same arc. Well, the answer is, it's the angle we're asked to find, which is BCD or DCB. What do we know about the angle of the center? The angle of the center is twice the angle of the circumference if they subtend the same arc. It means they're facing the same arc. So we can write that BCD or DCB, it doesn't really matter, is a half of 110. So 110 divided by 2 is 55 degrees. And the reason is that angle at the center is twice the angle at the circumference. Sorry, it's circumference. Okay, so just go that through quickly again. Tangent radius meet at 90 degrees. So these two angles are 90 each. And we have a quadrilateral BODA. The angles add up to 360. There are two of them, each one is 90. So I took 180 from 360. Now I'm left with 180. That means the 70-degree angle and BOD add up to 180. So I wrote BOD equals 180 minus 70, which is 110. And I said you could do it the long way, which is to say it's 360 minus the sum of the other three angles, which is 90 plus 90 plus 70, giving 110. And the angle of the center, that's BOD, which is 110, is twice the angle of the circumference, which is BCD, because they're both facing the same arc, they're subtended by the same arc. And so we say BCD, or DCB, is 110 divided by 2, which is 55. Well, I hope you found that useful. Until the next one, take care.